right, here we're looking at our notes for section 6.3. So we actually have 3 different sheets we're going to be using today. The first one looks kind of like this, but you're going to have to cut it out. So when you do that, we identifying and then equation. Once you cut it out along the longer lines and make it look like this, you kind of fold it and it turns into a lovely little book like this that we're going to be using. The second one looks like this, and yes, you do need to go ahead and fold it in half and then cut along all of these lines because we're going to make some tabs and some explanations about it. And the third one looks like this. We're going to be using this to graph our different functions. So I want you to go ahead and take a couple minutes and get these all cut out so that you're ready to rock and roll when we get into our notes. So the first one we're going to really be looking at is we're going to be identifying and evaluating exponential functions. And that's really our learning target that we're meeting right here and now. So also for today, make sure you do have colors. We will absolutely need colors today. It just really kind of helps us when we're differentiating, especially in our next couple of things. So here we're going to be identifying. So really we're looking at the difference between an exponential function and a linear function. That's really our important thing. So the equation that we know for an exponential function is y equals ab to the x. Okay, so that's really kind of going to be your important piece of what we're looking at. The thing we also notice with an exponential function is that it's a constant ratio. So a constant ratio, we're kind of multiplying by the same thing. Okay, so now let's look at our equation for a line. And we want to keep these two separate. So our equation of a line is y equals mx plus b. And we've seen this over and over, and we'll continue to see this. So we know that a line has a constant increase. Just like a step. Every time I go up 1 in an x, I go up this many in y. I go up, and I go up, and I go up, and up. That's what a whole line looks like. So now let's take a look at what those things can look like in a table form. Because you will be given this information and say, okay, so is this a line or is this an exponential equation? And how do you know? So in our table, we're going to look at this example. So I've got some x's and y's. So here I have 0, 1, 2, 3. And my y values are 4, 8, 16, and 32. So the first thing we need to notice is our x values, right? And here's where colors are going to really come into play. So every time I notice our x value increases by 1. So x increases by 1 each time. That's really important because we have to have that constant increase. So then we can look at our y values. And I notice to get from 4 to 8, I can multiply by 2. From 8 to 16, I can multiply by 2. And again, here I multiply by 2. So this is my constant ratio, my constant thing, because I multiply by the same thing. So that equals an exponential function. Okay, so now let's look at what a linear function would look like as a table or if I'm just given some points. So here I have my same x values, and my y values here are 2, 4, 6, 8. So again, we notice that our x values increase by 1 each time. So my x increases by 1 each time. So this is a constant increase. But then let's look at our y's. So whereas when we were in an exponential function, I was multiplying by the same thing each time, here I notice I'm going to add each time. So I add 2, I add 2, and I add 2. Because I add the same thing, right, and that's the important, that makes it a linear equation. Okay, so when I add the same thing over and over again, that becomes a linear equation. When I multiply by the same thing over and over again, that's an exponential function. Okay, so now let's look at evaluating an exponential function. Whenever you see the word evaluate, that means we're going to substitute in a value and kind of solve it. Okay, so when I'm evaluating, right, that's going to be our first little step, is we got to figure out what to do when evaluating. I plug in the new value for x. Or in reality, any variable, but generally we have an x. Okay. And we always, here's our key, use parentheses. Okay. That's our biggest step, is we always want to use those parentheses when we're evaluating and plugging in values. Okay, so here we're told evaluate y equals negative 2 times 5 to the x for x equals 3. Well, here I can see that it's not in a linear form, right? So if we go back to our first page, it doesn't look like this one. It looks a lot like this one. I've got two things and then an exponent of my variable. So I know that it's going to be an exponential function. So when I'm evaluating, I plug that 3 in. So I have y equals negative 2 times 5. And again, I always use my parentheses to the third. So when I am doing these and evaluating, I always want to follow my order of operations, right? So my order of operations, I would start with any parentheses, and I don't see I have anything I can do with that right now. And then I want to deal with my exponents. So I want to deal with my 5 to the third first. Well, I know that exponent tells me how many times I multiply that thing times itself. So here I have 5 times 5 times 5. So I end up with a negative 2, that stays the same, and 5 to the third is 125, because 5 times 5 is 25 times another 5 is 125. So then I can go ahead and multiply this out, and so my final answer would be a negative 250. So anytime you see those words, that word evaluate, that's where you're going to go ahead and take the number that you're given and plug it in for your variable, and then kind of follow your order of operations and solve for it. Okay? So hopefully using this you can kind of see the difference between an exponential function and a linear function. Definitely looking at the equation and the points in a table. That's going to be really important to be able to determine which one it is. Okay? So the next thing we're really going to be doing is we're going to be looking at what an exponential function actually is and what the pieces of it are. So here's where you're going to be using this sheet right here. Okay, and this is also where you absolutely need some more colors because we're going to keep some things pretty consistent so we can understand it. So our equation is y equals a times b, to the x minus h, and we're going to fill out in just a second what all of these letters mean and what they are, plus k, because these are some really important letters that we're going to see over and over and over again. So they do matter. Okay, so let's first look at what y is. Y is our dependent variable. So y depends on what x is. Okay, we don't really need to write anything for an equal sign because we kind of know what equals is. So a, what does our a value tell us? So a is our starting point. Okay, that's kind of where I start. So just like when we deal with linear equations, our y-intercept is kind of where we start. When we're dealing with exponential functions, a lot of times is where we start. Okay, so then let's look at b. What is b? So b is the base. That's what we call b, and it's handy that it's b and base together. So what the base does is that tells us how much the change is happening. Okay, so what we are multiplying. So what we are changing by. So b is the change that's happening. Okay. So now x is our independent variable. X is the thing that generally we change. So that's why it's the independent variable, because that's what we change or what we input and what we have a factor on. You'll notice that this one is a minus. That's kind of a big important thing. Okay, needs to be minus. Okay. That's really important. It seems a little backwards, and that's okay, but this has to be a subtraction sign. So then h. H tells us our horizontal translation. Okay? So our horizontal translation. So a translation is I'm taking my thing and I just shift the entire graph back and forth. So that's what my h tells me. How far back and forth have I gone? Okay? Then this is going to be a plus, and it's always kind of a plus, and it's not as important to remember as the minus, but it is. So then k is our vertical translation. So that tells us how far up or down it translates, our whole graph. So when we're graphing our functions, we always want to start with what we call the parent function. And the parent function is on this same piece of paper. Oops, my identifying is going to go in here as well. Right, so we're going to put, ooh, my papers are falling apart. So make sure you have space for all of your notes. Okay, so my identifying is going to go in there. I'm not actually going to glue it down quite yet, just to save myself some time. So then my exponential functions are going to go here. Okay, so I'm going to leave myself a couple of notes. So when I'm graphing, I always start with the parent functions. And again, I abbreviate function as fxn. You can abbreviate it however you're going to remember it. So when I'm graphing, I start with my parent function. And here, my parent function is y equals a b to the x. So how I can graph that is my a value is kind of my y-intercept. That's where I'm kind of starting. And that b value is what I multiply by. Okay, so that's really how I start my graph. I start here, and then I use my h and k to shift it both left and right and up and down. Okay, so I start with my parent function, then I use h and k to translate. Okay, so that's really important steps when we're graphing these functions. Okay, so we always want to make sure that we start with our parent function. We're going to look at different types of functions as well, but when we start graphing, we always start with the parent and go from there. So now let's kind of look at what those parent functions look like, and you're going to be using this last kind of piece that we're dealing with here. Okay, so here we see we have y equals a times b to the x in both of these. Okay, we're going to be looking at some differences here. In this first tab, we're going to look at what happens when this is b is greater than 1. And here we're going to look when b is between 0 and 1. And we'll look on the next page, what happens if we're negative? Okay, so these are kind of our big things. So then when I can flip this up, I notice I actually have a little graph written here, which is kind of handy. So the first thing I notice is when my a is positive, the direction that I'm going, and here my b is always going to be greater than 1. So if b is greater than 1 and a is positive, my graph will look something like this. Okay, and I'm going to go ahead and say that in here, that my a value is greater than 0. Okay, that's really important. This little piece right here, this little dot right here is going to be our y-intercept is at 0, comma a. Okay. So then using a different color, we're going to look at what happens if a is negative. Well, if a is negative, our graph looks kind of like this. So this is when a is less than 0. And then again, my point here would be 0, comma a. Okay, so that kind of helps us take, well, if b is greater than 1, am I going to curve up or am I going to curve down? Okay, so it doesn't matter on either of these, if a is positive or negative, what my domain is. My domain, remember, is all of my x values. Okay, and so all of my x values are possible. So it's going to be all real numbers. Because if my pen is way over here, I'm still touching my graph. It goes on and on and on in both directions forever, so it's all real numbers. So the difference here is my range. And range, remember, is our y values. So for the green one, I'm going to give myself a little bit like that. So I see in my green one, when a is positive, my range also goes positive. My range is going to be greater than 0. Well, when my a is negative, I see that I continue to go down and down and down forever and ever. So my range is going to be y is less than 0. Okay, so now let's take a look at what happens when that b value is a fraction. And we generally see fractions more than decimals in this, so that's what's going to look like over here. Okay, so if b is a fraction, but again my a is positive, so we're going to be dealing with green, my graph looks something like this. Okay, so this is again when a is greater than 0. Here again I have my point at 0, comma a. So now what if a is negative? You can imagine that it's going to look sort of like this. Okay, so this is when a is less than 0, and again my point here is 0, comma a. So again, just like when b was greater than 1, my domain, you can see it continues on and on and on and on in both directions forever. So my domain here again is all real numbers. And this is just the kind of mathematical way that you can write all real numbers. So let's look at our range again for this one. So again, I see if a is positive, my range continues up and up and up and up and up. So it's going to be greater than 0. And as if my a is negative, it goes down and down and down and down and down, so I see that my range is going to be less than 0. Okay? So here's how we can kind of just graph them. So now you can use this little flip book to help you determine what it's going to look like, and also take the graph and determine, okay, so what should my equation look like? Okay? There's one other little thing we're going to take some notes on today. So on the bottom of this page where this one's going to go, I need you to draw a little table, and we're going to plug some values in, and we're going to kind of write our equation based on our table. So there's my table with my x and my y values. And I have x values of 0, 1, 2, 3, and 4. And I have y values of 2, 10, 50, 250, and 1250. Okay? So how do I know what kind of an equation this is, first of all? And then B, how can I actually write my equation? Okay, that's what we're going to do from here. So the first thing we need to notice is that our x values increase by 1 each time. Okay, so this is an adding 1, I'm adding 1, I'm adding 1, I'm adding 1. So this is a consistent thing, so I can now look at my y values. So going back to our first thing that we used, right, let's look at our table and what that looks like. Okay, so to get from 2 to 10, I can either add 8. Well, do I add 8 again? No, I don't. So I know I'm not going to be adding the same thing, okay? So let's see if I can, if there's something I multiply by. Oh, well, I see from here, another way to get from 2 to 10 is I multiply by 5, and here I multiply by 5, and I multiply by 5. Oh, and I multiply by 5 again, so that actually works. So since I am multiplying by the same thing, it's going to be an exponential function. So I'm going to have y equals a times b to the x. But now we have to plug in what those a and b values are. Okay? So I know that a is kind of where I start. So when x is 0, my a value is my y value. So I see that. I'm going to go ahead and use red here, right here. So I have an x value of 0, so this now tells me my a value. So I'm going to have y equals 2. Then the b value is that change, and that change in this example was 5, so I'm going to have times 5 to the x. Okay, so that is how I can determine from a table of points, or even if I have a graph, what my equation looks like. So when x is 0, that's going to give me my a value, and then the thing that I multiply, that gives me my b value. So we're going to take all of that information, and then we can write our equation from there. And so remember, you can always use Desmos to help you graph as well, and kind of see what it's looking like. We will be spending some time using Desmos to help us, if we're just given points, how Desmos can actually write some equations for us. So that'll be coming here pretty soon as well. So now you have the information that you need to go work on these practice problems. So as always, ask me when you get stuck, or come find me when you've got any questions, and I'd love to help you.